Hello pre-calc students, this is Mr. Lull. I'm recording a video on polar coordinates. So with polar coordinates, we are not looking at coordinates not just as an x coordinate and y coordinate, but as a point that is described as its angle from the origin and its distance from the origin. So our objective here is to use polar coordinates that can simplify complicated rectangular equations. So you can need to convert from rectangular to polar and polar to rectangle. And this is both for coordinates and for equations. All right, so let's get started. The language of polar coordinates. A polar coordinate system is a system to plot points in a plane with the point 0 in the center of a circular grid. The pole is the point O at the origin. The polar axis is the horizontal ray from 0 pole, the origin, to the right. The polar coordinates of each point in the plane, P is equal to r theta. Okay? So the polar coordinate P is described in two ways. R, its directed distance from O, the origin, to the point, and theta, the directed angle in a counterclockwise direction from the polar axis to the line OP. So this is the pole. So right here, this is the origin. This is the pole, which is the origin. All right, we have a polar axis right here. This is the polar axis. And let's plot a hypothetical point here. Let's say we have the polar coordinate 345 degrees. Remember, or in fact, this polar 345 degrees, so that's in degrees, or we can describe this as 3 pi over 4. So in that case, 45 degrees, our step one to look at the polar coordinate is that we imagine we are facing 0 degrees. So imagine, so step one, you can imagine standing at the origin. So imagine standing at the origin, facing your polar axis. So facing right. So when you're facing right, that's going to be 0 degrees. So that's 0 degrees. 2, rotate in the direction of theta. Rotate by your angle. And then 3, walk r units. So this is kind of, if you can imagine, standing at the origin. And so remember, if r is positive, if you have a positive r, you walk forwards. And if you have a negative r, you would walk backwards. So 345 degrees, you're standing at the origin, you are facing right at 0 degrees, you rotate 45 degrees, which is about right here. That's a 45 degree rotation. And then you go 3 units, so you go 1, 2, 3. And then 1, 2, 3 units on the polar circle is going to be right here. That's going to be 345. So that's going to be 345, or 3 pi over 4. So our angle is pi over 4, or 45 degrees. That's 45 degrees, or pi over 4. But our distance from the origin is going to be 3 units. All right, so plotting points in the polar system. So we're going to rotate pi over 4 radians, and then move 2 units forward. So we rotate pi over 4 radians and move 2 units forward. So it'll be 1, 2. And so this point would be P, which is at 2 pi over 4. And that's because this angle right here is pi over 4 radians. Now let's look at B. -1 pi over 3. So we rotate pi over 3 and then we 1 unit backwards. That's because that's a -1. So we rotate pi over 3. This is pi over 3. All right, so we're going in this direction, but then we're moving 1 unit backwards. So our point Q is going to be right here. So imagine you were walking backwards. So that's point Q. That's -1 pi over 3. All right, clearing annotations. Moving forward. Another example, we go -30 degrees. So that means we are going -30 degrees. So we are facing right. We move clockwise 30 degrees. So this is the line that's -30 degrees. And we are then we're walking 3 units forward. So we move 1, 2, 3. This point right here, R, this is point R. So we rotate -30 degrees and then move 3 units forward. All right. Point D. S, so problem D is point S. We're going to move -7 pi over 6. So we're going to -7 pi over 6 is going to be right here. That is -7 pi over 6, that rotation. This rotation would be 5 pi over 6 radians. They combine to make 12 pi over 6, which is 2 pi. That's why they're in full rotation. And so imagine you are facing this direction, and then you have to walk 2 units backwards. So you're facing this direction, you walk 2 units backwards, so your point is going to be right here. It's going to be point S. All right, so that is problem D. All right. Finding all polar coordinates of a point. Plot the point 2 pi over 3, and find 3 additional polar representations for your point. All right. So step 1 would be you could add or subtract 2 pi. So you can always add or subtract 2 pi. So in fact, I can do 4. So one additional way to represent this polar coordinate is you can add or subtract 2 pi. So you can have polar coordinates, and remember, if you have a denominator of 3, 2 pi is equal to 6 pi over 3. Keep that in mind. So you can go from 2 pi over 3 to 2 plus 6 pi over 3, 8 pi over 3. Or you can have 2 pi over 3 minus 6 pi over 3, negative 4 pi over 3. Another way is to have a negative R value and then add pi. So you can have 2 pi over 3 can become negative 2, and remember, pi would be equivalent to 3 pi over 3. 2 pi over 3 plus 3 pi over 3 is 5 pi over 3. Or negative 2 pi over 3 minus 3 pi over 3 is negative pi over 3. And so think about it. You can add, this is adding pi. You could subtract pi. But these are 1, 2, 3, 4 equivalent polar coordinates. And just as a note, there are infinite equivalent polar coordinates. All right, so let's express this with all possibilities. So we just need to find all angles coterminal with 2 pi over 3 plus 2 pi n, and with negative 2 pi over 3 plus 2 pi n. The plus 2 pi n just means what that means is all other coterminal angles. All right. So we have, and by the way, the point 2 pi over 3 would be over here. So this would be the point 2 pi over 3. All right. Coordinate conversion. So the polar coordinates r theta are related to the rectangular coordinates x, y as follows. We can derive this. You have a polar coordinate with a distance of r from the origin and an angle of theta from facing the positive x-axis, facing 0 degrees. Your angle theta. All right? And this coordinate, this coordinate could be described as r theta. It could be also described as xy. And xy talks about our directed horizontal distance from the origin, and it also talks about our directed vertical distance from the origin. So let's look at what we can convert here. We know that for this angle right here, that x is the adjacent side of this right triangle, y is the opposite side of this right triangle, and our distance from the origin to the point is the hypotenuse of this right triangle. So the cosine of theta is equal to the adjacent side over the hypotenuse, which means that the cosine of theta is equal to y over r, which ultimately means, that's x over r, because x is associated with the adjacent side, right? X is associated with the adjacent side, y is associated with the opposite side. So the adjacent side is r, is x, the hypotenuse is r. Multiply each side by r, and x is equal to r times the cosine of theta. Same thing with sine of theta. The sine of theta is equal to the opposite side of a right triangle over the hypotenuse. The sine of theta is equal to y over r. So, based on all of that, y is equal to r times the sine of theta. Okay. Now we have x squared plus y squared is equal to r squared. So let's figure this out. For this triangle, xy, right, we can use the Pythagorean theorem. This is a leg of a right triangle. This is a leg of the right triangle. And this is the hypotenuse. And with the Pythagorean theorem, we can say the leg squared plus the leg squared is equal to hypotenuse. So with this right triangle, this polar coordinate, we can say that x squared plus y squared is equal to r squared. That's true when you're coming from this right triangle. We can also say that the tangent of theta is equal to y over x, right? Remember, the tangent of theta is equal to the opposite side of the right triangle or right opposite side of the angle to the adjacent side of the angle. And so the tangent of theta is equal to opposite over adjacent. All right, excellent. So those are our formulas, and that's how we come up with them. So make sure that you're familiar with trigonometry. Example 3. Find the rectangular coordinates of the points with the given polar coordinates. Use x is equal to r cosine of theta, and y is equal to r sine of theta. So we have A, P of 3, 5 pi over 6, B, Q, 2, negative 200 degrees. So you have x is equal to r cosine of theta, and y is equal to r sine of theta. So we're converting to rectangular, and to convert to rectangular coordinates, we just need to convert from polar to rectangular, and rectangular is in the form xy. So we have x is equal to r times the cosine of theta. So x is equal to 3 times the cosine of 5 pi over 6. And the cosine of 5 pi over 6, unit circle. So remember the unit circle. So now we need to take out or remember the unit circle. All right, the cosine of 5 pi over 6 is going to be negative root 3 over 2. So this is going to be x is equal to 3 times the cosine of 5 pi over 6 is going to be equal to negative root 3 over 2. And so then 3 times negative root 3 over 2 means that our x coordinate is going to be equal to negative 3 root 3 over 2. Finding the y coordinate, we know that y is equal to r times the sine of theta. So y is equal to 3 times the sine of 5 pi over 6. So also we got to remember your unit circle values. So that means y is going to be equal to 3 times the sine of 5 pi over 6 from our unit circle is going to be 1/2. So 1/2 times 3 is 3/2. So our y value is going to be 3/2. And from our x value and from our y value, we have negative 3 root 3 over 2 and 3/2. Negative 3 root 3 over 2, and then we have 3/2. Okay, so that is A. For B, we have 2, negative 200. So remember, this is a quadrant 2 angle. because this negative 200 is bigger than 180 but less than 270. So x is equal to r times the cosine of theta. X is equal to 2 times the cosine of negative 200 degrees. So x was going to be equal to, and x will approximately be equal to negative 1.879. Y is equal to r times the sine of theta. Y is equal to 2 times the sine of negative 200. So y is approximately equal to 0.684. So we are going to have coordinates of negative 1.88 and 0.68. All right. Clearing annotations. Converting from rectangular to polar coordinates. All right. Find two polar coordinate pairs for the points with the given rectangular coordinates. Use r squared is equal to x squared plus y squared, and the tangent squared is equal to y over x. Plot the points on both coordinate grids. This is converting from rectangular. We just converted. We found the rectangular coordinates from the polar coordinates. All right. And now we're going to convert. So we just converted from polar to rectangular. Now we're going to convert from rectangular to polar. All right. We're going to use r squared is equal to x squared plus y squared, and the tangent of theta is equal to y over x. So if r squared equals x squared plus y squared, then r is equal to the square root of x plus y. And if r is equal to the square root of x plus y, then r is equal to the square root of 1 plus negative 1 squared, x squared, so our square root of x squared plus y squared. All right? So that means the r is equal to the square root of 1 squared plus negative 1 squared. So that's going to be 1 plus 1. So r is equal to the square root of 2. All right? Our theta is going to be equal to the inverse tangent of negative 1 over 1. So theta is going to be equal to negative pi over 4. Because the inverse tangent of negative 1 is equal to negative pi over 4. Negative pi over 4, note that this is, if you're confused, note the equivalent, the inverse tangent of negative 1 is going to be equal to 7 pi over 4 as well. And these are equivalent values. 7 pi over 4 and negative pi over 4 are equivalent. They're coterminal. So r is equal to the square root of 2. Theta is equal to, let's just say, negative pi over 4. And so we have our point, the square root of 2, which is approximately, so we have our point 1, negative 1. We also have our point, which is the equivalent point, negative pi over 4 square root of 2, which is going to be about here. That's point P. All right, now we have the point 2, 0. So x is 2, y is 0. This is the point 2, 0. R is going to be equal to the square root of x squared plus y squared. So r is equal to the square root of 2 squared plus 0 squared. So 2 squared is 4. So r is equal to the square root of 4. All right. So that means r is equal to 2. Now theta is going to be equal to the inverse tangent of 0 over 2, which is equal to the inverse tangent of 0. And the inverse tangent of 0 is equal to 0. So the inverse tangent of 0 is equal to 0. And so theta, once again, r is equal to 2, theta is equal to 0. And we have are facing 0, and we have a radius of 2. So we go facing 0 degrees, then we move 1, 2 points. This is point B. So point Q. For problem B, point Q. Now, from this point, we have the following conditions. So if we need to find two polar coordinate pairs, let's find our pairs. So one is going to be obviously right here, root 2 and negative pi over 4. But another one could be negative root 2, 3 pi over 4. So added pi made r negative. Or you could do root 2 and 7 pi over 4. And remember, we said these are equivalent. So it makes sense that (7 pi over 4). Here we have coordinates of r is 2, theta is 0. We can also have r is negative 2, theta is pi, or r is negative 2 and theta is negative pi. So I want you to think about how these values make you end up at this point, and these values make you end up at that point. All right, moving on. Convert from polar to rectangular form. Convert each equation to rectangular form and identify the graph. Support your answer with a polar graphing utility. So here we have r is equal to 4. So r is equal to 4 is a circle in rectangular form. This is going to be a circle in rectangular form. How do we know this? Well, r is going to, remember, r squared is equal to x squared plus y squared. So if r equals 4, then r squared is equal to 16. And if r squared is equal to x squared plus y squared, we can make the substitution that x squared plus y squared is equal to 16. So it's a circle. So this is a circle. Center 0, 0 with a radius of 4. Plotting this with a graphing utility. Get our calculator, turn it on, go to mode, go to polar. All right. And r, we just say r is equal to 4. And let's graph that. Well, you know, it's a circle with the radius of 4 and centered at 0, 0, shown on our graph right here. All right, so that was A. Let's try B. R is equal to 2 times the cosecant of theta. So we can rewrite this as R is equal to 2 times 1 over the sine of theta. That means R is equal to 2 over the sine of theta. All right. And then multiply each side by the sine of theta. So you multiply the left side by the sine of theta and the right side by the sine of theta. So R times the sine of theta is equal to 2. So y is equal to 2. This is a horizontal line. So remember, r sine of theta, remember our polar conversion, y is equal to r times the sine of theta. So y is equal to 2. So this is going to be a horizontal line. So this is a horizontal line. All right, so that's A, that's B. Let's try C. Theta is equal to 2 pi over 3. So this is going to be x. This is going to be y. Theta is 2 pi over 3. So if we rotate 2 pi over 3, we're going all the way here, where theta is going to be 2 pi over 3. This is theta, and that's equal to 2 pi over 3. So in general, we can say that slope m is equal to the change in y over the change in x. And this is going to be equal to the change in y would be root 3 over 2 divided by 1/2. So change in y would be 3 over 2 divided by -1/2. Where do you get these values? Well, the sine of 2 pi over 3 of 2 pi over 3 is equal to root 3 over 2. The cosine of 2 pi over 3 is equal to -1/2. These come from your special right triangles and unit circle. This comes from special right triangles and unit circle. This comes from the special right triangles in the unit circle. So you have root 3 over 2 and -1/2. So root 3 over 2 divided by -1/2 is going to be root 3 over 2 times -2 over 1, which is going to be equal to -2 root 3 over 2, which has become -2 root 3 over 2 is going to become just -root 3. So your slope m is equal to negative the square root of 3. So we've got to be able to divide fractions here. We've got to know our unit circle values. All right? Because we pass through the origin. Pass through the origin. So y is going to be equal to the negative square root of 3 times x. And so at 2 pi over 3, by the way, xy is equal to -1/2 root 3 over 2. Okay? So, just another point for the graphing calculator. If we say r is equal to 2 over the sine of theta, and we can erase the stuff for the first equation. But if we can, things are loading. You can always fast forward if you want to. I want to say r is equal to 2 divided by the sine of theta. Okay. Graph that. That's going to be that horizontal line, right? That's a horizontal line at y equals 2. All right. And then this is going to be harder to plot because instead of having the r, you just have a theta, which is going to be a line that goes through 2 pi over 3. And so you can find the slope here. So it's going to be a line. It goes through the origin. And it has a slope of the y coordinate on the unit circle and over the x coordinate of the unit circle. And that's going to be what happens when you simplify root 3 over 2 over negative 1/2. So clearing annotations. Now we need to convert equations to polar form. So we have 2 more problems left. We need to convert x minus 3 squared plus y minus 2 squared is equal to 13 to polar form. So hopefully we should see that this is a circle. This is a circle. All right. Let's give us all the possible space though. So first we need to expand. So we have, when we expand, we're going to have multiply x minus 3 squared, so that should become x squared minus 6x plus 9 plus y squared minus 4y plus 4 is equal to 13. We should then be able to subtract 9, subtract 4, and we subtract 9 and 4 from the left side. That means that the 9 will cancel out, the 4 will cancel out, and 13 minus 9 is 4, minus 4 is 0. That will cancel out as well. So we will be left with x squared minus 6x plus y squared minus 4y is equal to 0. We will then rearrange this, so x squared plus y squared minus 6x minus 4y is equal to 0. X squared plus y squared. Remember, x squared plus y squared, we have a polar conversion that r squared is equal to x squared plus y squared, right? That's our polar conversion formula. So this can become r squared. We also have a formula that x is equal to r cosine of theta and y is equal to r sine of theta. So we can have r squared minus 6 times r cosine of theta minus 4 times r sine of theta is equal to 0. So now we can factor out an r, because we have, if we factor out an r, we will have r times, so we factor out an r out of, we factor out an r out of our first term, our second term, and a third term, because we have an r in r squared, we have an r in r cosine of theta, we have an r in r sine of theta. So we factor out that r, we will have left over r squared divided by r is r. 6 times r times cosine of theta divided by r is just minus 6 times the cosine of theta. And 4 times r times the sine of theta divided by r is just going to be minus 4 times the sine of theta. And that's all equal to 0. So now we need to solve for r equals 0. We need to expand. Right here, we need to use our polar substitutes. For 3, we need to factor. All right, and then step 4, we need to solve for r is equal to 0. We solve when r is equal to 0. So in this case, r is equal to 0. So when we solve for r is equal to 0, we either have r cannot equal 0, because that will be a point only, or r is going to be equal to, if r minus 6 cosine of theta minus 4 sine of theta is equal to 0, then r would have to be equal to 6 the cosine of theta plus 4 times the sine of theta. Because if this term is equal to 0, you could rearrange it as this term right here. So we can also check this on the calculator. So we have, remember, our center is going to be 3, 2. That's going to be HK. Our radius is going to be equal to the square root of 13. So this is going to be 3, 2 with a radius of the square root of 13. And when we check it on the calculator, what we can do is we can plug things into the calculator. And say r is equal to 6 times the cosine of theta plus 4 times the sine of theta. Graph that. We should see that the circle kind of matches up. All right, clearing annotations. Finding the distance using polar coordinates. Radar detects 2 airplanes at the same altitude. Their polar coordinates are 7 miles at 115 degrees and 6 miles at 6 miles at 20 degrees. How far apart are the airplanes? So we need to use the law of cosines. So, step 1, we want the resultant W. We are going to want the resultant vector. We're going to want the resultant vector. All right, and the resultant vector is going to be 6 miles in one direction, at 20 degrees, right? So we're going to have the resultant vector. So let's draw the first vector. The first vector has a magnitude of 6 and a angle of 20 degrees. Our second vector has a magnitude of 7 and an angle of 115. So we're going to have an angle of 115. That angle right there is 115 degrees. And we're going to have a magnitude of 7. Okay? The angle in between 715, so this angle right here, that angle is going to be equal to 115 minus 20. 115 minus 20, which is going to be equal to 95 degrees. So if we draw, because we need this theta value right here in between the two vectors, we need theta because 115 degrees minus 20 degrees is equal to 95 degrees, because that's the theta between vectors. So to draw things more clearly, we have a vector at, we have a vector at 6, we have a vector at 7, these are the magnitudes, and the angle between these vectors is going to be 95 degrees. The resultant goes from the beginning of the first to the end of the last. This is the distance between the air points. So let's call this distance x, right? And we can find x using the law of cosines. We can say, using the law of cosines, that x squared is equal to 6 squared plus 7 squared minus 2 times 6 times 7 all times the cosine of 95 degrees. Polar coordinates, infinite sequence, infinite finite sequences series. All right. 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of 95. Now, x squared, that's what x squared is equal to. X is going to be equal to the square root of all of that. So the square root of 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of 95. Get our calculator up. I accidentally X that out. Always fast forward. So in my calculator, I need to find the square root of 6 squared plus 7 squared minus 2 times 6 times 7 times the mode degree times the cosine of 95 degrees so that's going to be equal to 9.608 approximately. So x, plug this into the calculator. And x is equal to 9.608. So our answer, the planes are about 9.6 miles apart. All right, that is the video. Hopefully you learned something.